Okay. Now, did you go through the problem? Go through the numerical? So see, it says design a comparator to check if two n-bit numbers are equal. Okay, you have to design a comparator to check if two n-bit numbers are equal. Configure this using cascaded stage of first bit equality comparator. Okay, now see, when you say equality comparator, it means your output comparator will be high only in the case your output A is equal to B. Okay, equality means what? A equals B. Okay, so now first part we'll do what we have done here. I have drawn the truth table for one bit comparator. Okay, I have drawn the truth table for one bit comparator, and then any problem in drawing the truth table? Anyone?
No problem.
So then depending on this, see, now this is your one bit comparator का, ठीक है. Now here you see, I have drawn the n bit comparator. Okay, n bit comparator. So a naught b naught will be your input, and your again you will have three outputs: a greater than b, a less than b, and a equals to b. So now see here, one bit equality comparator when a is equal to b naught, okay, XNOR, here you can see here XNOR, okay, gives output 1. So here I'll have 1, okay, here I'll have 1. Then output A is equal to B is bits are equal, okay. So what we have done here, if your A naught, B naught, okay, if these are equal, it means your, see, if A naught, B naught, these are 1, 0, 0, then A is equal to B. A is equal to B mein your XNOR output is 1. Okay, here XNOR ka output is 1. Now you can see here, right, what I have done, I have drawn a n bit equality comparator. Okay, see, this is one equality comparator. Okay, one bit equality comparator. This is one bit second equality comparator. This is one bit third equality comparator. So on up till n bit equality comparator. समझ में आ रहा है? Are you understanding?
Yes, ma'am. I'm understanding, ma'am.
हाँ. So see what I have done here. See, it is said that A is equal to B is 1, output A equal to B is at logic 1, indicating that bits are equal. Okay, this truth we know. A is equal to B high kabhi hota hai when your A is equal to B. Okay, A and B magnitude are same. Okay, so what I do, A is equal to B, I give as input to the first comparator, B naught to A naught. Okay, our first LSB, इसका जो आउटपुट आएगा, सी आउटपुट हियर इज A is equal to B. Okay, so वो आउटपुट, that output I'll give it as input to the second 1 bit comparator. समझ में आ रहा है? If this bit is low, then this will not be high. So this has to be 1. समझ में आ रहा है? This is A is equal to B. Hope I am clear.
Yes, ma'am.
So now, so you can see, so what I have done, I have cascaded n 1 bit comparators. ठीक है, I have cascaded n 1 bit comparators जिसका सब इनपुट होगा A is equal to B. Okay, whichever output you get from the previous stage, that will be input. ठीक है, right? Understood this everyone?
Yes, ma'am.
Right. Okay, right? Now we are talking about the ICs, right? So IC 7485, okay? We'll see what is 7485 IC. So हमारा 7485 IC is a 4-bit comparator IC. Okay, 7485 is a 4-bit comparator IC. So it can be used to compare two 4-bit binary words, right? It can be used to compare two 4-bit binary words and just a minute, right? And connector input, right? You need to see, basically this means what? Basically this means our 7485 IC is a IC which we require to cascade. Okay, cascade करने के काम आता है. So see, I A less than B, I greater than B are taken as my, okay, these two outputs are taken as my grounding. Okay, connector input I is equal to AB, right, is connected to VCC. Okay, I equal to AB is connected to so these ICs can be cascaded to see, I told you it is required for cascading. So these ICs are cascaded to compare words of almost any length. Okay, this can be used to cascade any length, right? Its 4-bit inputs are weighted A0 to A3 and B0 to B3. I said there are two inputs, A and B. So A is A0 to A3 and B is B0 to B3, where A3 and B3 are, see here, A3 and B3 are most significant bits, MSB. right? So this is a pin diagram. This you can see, it's a pin diagram for 7485 IC, right? Where I have pin number 8 grounded. See, most of the ICs, whichever IC you see, pin number 8 is generally grounded and pin number 16 is connected to always VCC. Okay, so this is a common thing in any IC you see. This is the pin diagram and here you can see the block diagram. Okay, now B0 to B1, right, is my input B. A0 to A1 is my input A. Okay, these are, see, I of A less than B, I A equal to B, I A greater than B. Okay, these three act as my cascading inputs. Okay, cascading inputs means what? Here to cascade what I do, A greater than B and A less than B मैं ground करती हूँ. See, I have written here grounding I A less than B and A greater than B, and A equal to B. What I do, I connect it to the connector. I connect it to the connector. Okay. So this is pin diagram and this is block diagram, right? So see, I have sent you the truth table. Okay, PDF I have sent. You just go through the truth table, right? I'll go through the numerical. Okay, I'll just see the two numericals. You all can do this truth table, right? Truth table कर लोगे ना?
Yes, ma'am. कर लेंगे.
Just go through, else कल की क्लास में हम लोग डिस्कस करेंगे truth table. If you have not understood, only in that case. ठीक है? Now see, you are asked to design a 8-bit comparator using 27485 ICs. Okay, 27485 ICs. So what we are doing, 27485 ICs you have to take. Okay, and okay, see, our LSB दो input रहते हैं. Okay, A and B are two inputs, right? So A0 to A3 are my inputs, LSB of input A, and B0 to B3 are input, LSB input of input B. So it is B0, B1, B2, B3 LSB given to first IC, and B4 से B7 input MSB of B given to second IC. Is there any problem in giving the inputs? Is there any problem?
No, ma'am.
Connecting the inputs, up till connecting the inputs, there should not be any problem. ठीक है? Now see, major problem किधर आता है? Doing with the cascading. Okay? So you have to keep in mind 7485 IC जो है, for that I of A less than B and I of A greater than B should be grounded, and connector I equal to I of AB should be connected to VCC. So see here what I have done, I A greater than B and I A less than B I have grounded, and I A equal to B you have to connect it to plus VCC. ठीक है? So then what I did, I connected A equal to B. A equal to B, A equal to A greater than B and A less than B are outputs of first IC which are given as input to second IC. Okay? Right? So this is a 8-bit comparator which is designed using 27485 ICs. Up till here, is that okay?
Yes, ma'am. Okay, ma'am.
Okay. So similarly, you are asked here to design a 5-bit comparator using 7485. Okay. Now see, ये जो 7485 IC है, this is a 4-bit IC. Okay, see 7485 is a 4-bit IC, but here you are asked to design a 5-bit comparator. Okay, you are asked to design a 5-bit comparator. So what we'll do? See, we know that an IC 7485 IC is a 4-bit IC. So first I'll give, right, inputs B0, B1 to B4 and A1 to A4. Okay, 4 bits. Input A and B देती हूँ, right? But these are 4. Okay, 4 bits हुए. 5th bit what I'll do? Okay, for the 5th bit, see, I'll keep the 5th bit to do the comparison. Okay, to do the comparison or to do the cascading. So मैं क्या करती हूँ, A0 B0 I'll take, and I'll take cascading inputs. So when A0 is 0, B0 is 0, we know that A is equal to B goes high. Okay, when your input is 0 1, we know that A is less than 1, so तुम्हारा ये high हो जाएगा. Okay, when your A is greater than B, see it is 1 0, I get A greater than B. Else for 1 1 I get A is equal to B. So this is the truth table for a 1-bit comparator where I have taken A0 B0 1 bits of a 4-bit 5-bit comparator here. Okay, then my outputs, what are my outputs? A greater than B, A is equal to B and A less than B are my outputs. So output के लिए मैंने truth table डाला. Okay, truth table for that outputs will be similar to 1-bit comparator जो हमने already किया हुआ है. Okay, now this outputs, see this gate, this logic diagram I have already drawn here. See, a same logic diagram है. Okay, same logic diagram. I am taking it and connecting it to a 4-bit IC. देखो, it's the same logic diagram. 1-bit comparator. समझ में आया? Is that understood for today? Today what we have done comparators, is that understood?
Yes, ma'am. Understood, ma'am.
Okay, right. So this is all about the comparators, and almost from previous year question papers I have covered all the numericals. Okay, so you can go through. If any discussion is to be done, we'll do it in the next class. Is that okay?
Yes, ma'am.
Okay, right. So respective PDF I have sent to you. Just go through the PDF and start preparing for your internals, everyone. Right. So we'll finish up the class here.